Okay, so here's the final weird kind of question for 2.2. Namely, it's worded this way, so it's asking us to find the value of a constant that makes this limit exist. Okay, so the constant is k. Note, x is the variable in the limit, so this k is just some number. It might be 4 or -8 or whatever. We need to find the value of the k that makes this limit exist, and once we've found the k, then we need to actually evaluate the limit. Okay, so the key observation here, and the key thing to remember, is what kinds of fractions do I want for limits to exist? I want either both pieces to not be 0, or the numerator to be 0 but not the denominator, or both the numerator and the denominator to be 0. But I already have, since x is going to 2 and there's no k's here, x minus 2, that is going to be going to 0. So the only way that this can possibly work out to be a nice limit that exists and all of that stuff is for the numerator to also be approximately 0. What is the numerator going to? Well, if I plug in 2 for x, the numerator is going to 2 squared plus 2k plus 6. Okay, which if I simplify that, that's 2k plus 10. Again, the only way this can work out is if this thing ends up being a 0 over 0. So I need to solve for when 2k plus 10 is equal to 0. Which, as it happens, is when 2k is minus 10, so it's when k is minus 5. Okay. So the value of k I want is minus 5. But don't forget, that's not the whole question. The question then asks for the limit as x goes to 2 of what I get if I actually put in that minus 5 there. This is now a 0 over 0 limit. So what we basically found out is now this should factor. And in fact, it factors as x minus 2 times x minus 3. But now I've got this x minus 2 and this x minus 2, so those cancel. And so this is the same thing as the limit as x goes to 2 of x minus 3 divided by 1. And what's that? That's just 2 minus 3, which is minus 1. So this question really has two parts to the answer. One part is the k equals minus 5, and then the other part is the minus 1. I'll do one more like that, just so that we are on the same page. So let's do this time the limit as x goes to 4 of x squared minus kx plus 10 over x minus 4. And again, I need to start by finding the value of k. To be clear, this is the same question as before. So what's the denominator going to if x is 4? Well, it's going to 0. What's the numerator going to? Well, it's going to 4 squared minus 4k plus 10, which, as it happens, is 26 minus 4k. So what do I need? I need for that thing that this is going to, I need it to be 0. So 26 minus 4k is 0. So 4k is 26. So k is 26 over 4, which I can simplify to 13 over 2. That's my k. So I am now halfway done the problem, but I now have to actually evaluate the limit in the instance that k is 13 over 2. Now, there's a very real possibility that this 13 over 2 throws us for a loop, because we don't like factoring polynomials that have fractions in their coefficients. But we can actually use what's almost the same trick that we used for the radicals, which is we can multiply the numerator and denominator of this fraction by the same thing in order to get rid of the fraction. Namely, in this case, I need to multiply the numerator and denominator by 2 in order to clear out the fraction. Upon multiplying the numerator here by 2, I'll get 2x squared minus 13x plus 20. Okay. And then the denominator will be 2 times x minus 4. Now this looks like something nice that I can factor. Okay, let me go ahead and show you a little shortcut that you can take. I know how this is supposed to work out. This x minus 4, it's got to cancel with an x minus 4 up here. Okay, there's no other way for this to work out. Which means that when I go to factor this thing, I actually know one of the factors is x minus 4. Okay, and if this factor is x minus 4, what does the other factor have to be? Well, remember, this number and this number, they have to multiply together to be plus 20. So if one of them is minus 4, the other one has to be minus 5. And you can check that that actually worked, in case you didn't believe that my shortcut would work, because if I actually multiply this out, I get a minus 8x coming from these two, minus 5x coming from those two, and minus 8 minus 5 is minus 13, so it works out. But now, once our little wishful thinking here has paid off and saved us a little bit of work, we can cancel the x minus 4s. And so this will be the limit as x goes to 4 of 2x minus 5 divided by 2. And so that, in fact, will be 8 minus 5 divided by 2, which is 3/2. And that will be our answer. Again, remember our answer here has two parts. The 3/2, which is the value of the limit, and the 13/2, which is the value of k that made the limit. But I'll wrap up there for now. That's the end of 2.2. The next 3 sections are about limits, but they are all much shorter, and we're going to use them a little less. So although we've only done 4 sections so far in test 3, and there's 3 sections remaining, the 3 sections remaining probably together will be about as long as this video was. But I'll wrap up there for now, and I'll see you all next time.